Hello, good friends. Today, we're going to unpack the important topic of preference discerning in sequential recommendation systems. We're exploring a noteworthy research paper titled Preference Discerning with LLM-Enhanced Generative Retrieval, authored by researchers from the ELLIS Unit at the LIT AI Lab, Institute for Machine Learning at JKU Linz in Austria, the University of Wisconsin-Madison, and Meta AI. Now, let's begin by understanding what a sequential recommendation system is. In essence, it's a system that suggests items to you based on your past interactions, much like how streaming services recommend the next movie you might enjoy, or online retailers suggest products you might be interested in. These systems analyze the sequence of your previous choices to predict what you might prefer next. These recommendation systems often incorporate auxiliary information to enhance their predictions. This can include textual descriptions of items, like summaries of books or reviews of restaurants, and additional tasks such as predicting your preferences or discerning your intent. However, despite these enhancements, these systems still have limitations in personalization. They don't always capture the nuanced and unique aspects of your individual preferences. Why is that the case? Well, user preferences are often not explicitly provided in the data these systems use. Instead, the systems have to infer your preferences indirectly from your interaction history. This means they might overlook certain aspects of what you truly like or dislike. This brings us to the innovative concept introduced by the researchers: preference discerning. In this new paradigm, the recommendation system is explicitly conditioned on user preferences that are expressed in natural language within its context. Rather than solely relying on your past interactions to guess what you might want, the system directly incorporates your stated preferences into its decision-making process. But how does this work in practice? The researchers employed large language models, or LLMs, to generate representations of user preferences from sources like user reviews and item-specific data. Imagine you've left reviews or comments about items you've enjoyed or didn't care for. The LLMs analyze this text to extract a detailed understanding of your preferences. The recommendation system then uses this explicit information to tailor its suggestions, aligning them more closely with what you genuinely prefer. To rigorously assess how well systems can incorporate and act on these explicit preferences, the researchers introduced a novel benchmark. This benchmark evaluates a system's ability to discern and follow user preferences across various scenarios. For instance, it tests whether a system can steer its recommendations based on your specific likes and dislikes, and whether it can follow the sentiment you've expressed, be it positive or negative, towards certain features or items. Upon evaluating current state-of-the-art methods using this benchmark, the researchers found that these methods struggled to accurately discern and act upon user preferences. This highlighted a gap in existing approaches when it comes to personalization. In response to this challenge, they developed a new method called Mender, which stands for Multimodal Preference Discerner. Mender is a generative sequential recommendation model that represents items at different levels of abstraction. Specifically, it uses semantic identifiers, which are unique identifiers that capture the essence of an item, and natural language descriptions to represent items comprehensively. By leveraging both these representations, Mender can better understand and incorporate user preferences expressed in natural language. In their experiments, Mender outperformed other models on the benchmark, demonstrating a superior ability to discern and follow user preferences. Notably, Mender could be effectively guided by human preferences it had not encountered during training. This suggests that Mender can adapt to new users and their unique preferences without requiring retraining for each individual. So, what are the implications of this work? By explicitly incorporating user preferences articulated in natural language, we can develop recommendation systems that offer a higher degree of personalization and responsiveness. This approach moves us closer to systems that truly understand and cater to the subtleties of individual tastes and desires. In conclusion, the paper Preference Discerning with LLM-Enhanced Generative Retrieval presents an important advancement in how recommendation systems can personalize suggestions. By introducing the preference discerning paradigm and the Mender model, the researchers have opened new avenues for creating more effective and individualized recommendation systems. Their work underscores the potential of utilizing natural language to enhance the way technology understands and serves our needs. Thank you for joining me in this exploration of developments in recommendation systems. Until next time, stay curious and keep engaging with the fascinating ways in which technology continues to evolve.